Hello everyone. In this video we will be discussing three-dimensional shapes and units of measurement. So yesterday we discussed the volume of three-dimensional shapes. I explained to you how it is basically measured in cubic meters and how it works basically. What the concept means to measure how much space an object takes up. So now I will be showing you how to find both the area and the volume for three-dimensional shapes: the cube, the rectangular prism, and the cylinder. First, we need to define what each of them is. The cube, as you can see, is just the 6 squares that we put together yesterday. We assembled them basically. So all of its edges are exactly equal. In this case, I have named them A. So A is all the edges of this shape. In the case of the rectangular prism, you can see that it's kind of like a cube, but if we stretched it out in a way, kind of the same way that a rectangle resembles a square if it was stretched out, but only in 3 dimensions. So the rectangular prism can have different edges. So we named them, as we explained yesterday, the height, the length, and the width. And all the vertical edges are the same as the height. All of the horizontal edges, at least when it comes to this, uh, are equal to the length, and then the ones that move into the back are equal to the width. Lastly, we have the cylinder. So I'm sure you've seen shapes like this, cans of all sorts, or a bucket, a glass, many things basically. So here you can see that it has one base on top, one base on the bottom. There's circles, and then the body of the cylinder connects the two basically. What needs to be pointed out is that the circle on the top needs to be exactly the same as the circle on the bottom, because if it's not, then it is not considered a cylinder, but rather a cone. And we're not going to be talking about cones. So basically what that means is that the radius of the circle on top is the same as the radius of the circle on the bottom. So first we're going to talk about the area. The area of the shape is basically uh, the surface of the shape. Like if I wanted, imagine you bought this as a gift, right? And you wanted to wrap it. And you wanted to figure out how much wrapping paper you needed to use. Well, that's the area. That's how you find that's what the area means basically. To find the area of a cube, I take 6 and I multiply it with a squared, where a is one of the edges. And you might think, okay, but why? And the reason is you can see here that it's made up of 1, 2, 3, 4, 5, and there's the bottom there, 6 squares, right? So when we say the area, what we basically need to do is find the area of one square, and since they're all exactly the same, just multiply that by 6. Well, how much is the area of a square? That's one side, a, times another side, a, so a squared. Now for the volume, we need to do a cubed, a to the third, right? So in case you don't remember what that means, we would say that that is a times a times a. So if, for example, a is, I tell you that I give you a cube that is, let's say, 3. All of its edges are 3. Its area would be 6 times 3, 3 squared, and its volume would be 3 cubed, right? So the area would be 6 times 3 squared is 3 times 3, so 9. So 6 times 9, which makes 54. That's the area. And the volume would be 3 cubed. So it would be equal to 3 times 3 times 3 times 3, which is equal to how much? 3 times 3 is 9, times 3 is 27. That would be the area. That would be how I would find the area. Sorry, the volume in the second case. Next up, we have the rectangular prism, right? So you can see here that this is basically made up of 6 different rectangles. They're equal in pairs. So this one, this face is equal to the back face, the right face is equal to the left face, and the top face is equal to the bottom face. So to find the area, I just need to find the area of each rectangle and add them all up. So, for example, the area of the front face, of the front rectangle, would be h, the height, times L, the length. That would be the area of the front face, the front rectangle. But it's also the area of the back rectangle because they're the same. So these two would be h times L and another h times L. Which, if we wanted to, we could write as just 2 times h times L, which means basically that however much this is, times 2. Which, yeah, because it's the same thing and we're adding it to itself. So 2 times this thing. So that's the area of the front face, right? Then for the right face, we have to remember that since this side is the height, this side is also the height. So however much this is the same. So the area of this right face would be h times w. But that's also the area of the left face. So together they would make up h times w plus h times w. And if I added them, I would get 2 times h times w, the same as before, for the same reason as before. And then we do the same thing for the top face and the bottom face. So the top face, you can see here is a length, right? So this side is going to be L, this side on top. And then we have up here an edge that is the same as the width. So for the top face, the area would be L times W. So for the top and the bottom, it would be 2 times L times W. Right? Now, what if I add all of these together? Well, then I get this. I get 2 times the sum of each individual rectangle. Sorry, this should be W times L. So h times L, then h times W, W times L, then add them all together and multiply them by 2. So let's do an example. Let's say I tell you, and these actually are not necessary, you don't need to see them. we only see the letters once, and by that we can deduce what the others are. So let's say that the height is, let's say, 2, the length is 4, and the width is, let's say, 10, right? Well, all I'm going to do is I'm going to plug in the numbers that I was given into this, and then just solve. So the height is 2, so let's change the h's into 2's, and the L is 4, so change the L's into 4's. And the width is 10, so change the W's into 10's. So what I get is 2 times parentheses 2 times 4 plus 2 times 10 plus 10 times 4, which, if we remember our order of operations, we first need to do the operations inside the parentheses, but then also inside the parentheses, the multiplications have priority. So we first need to do 2 times 4, 2 times 10, and 10 times 4, and then we can proceed. So it would be 2 times 4 makes 8, plus 2 times 10 makes 20, plus 10 times 4 makes 40. And now I can add these up, in which case I would get 2 times 8 plus 20 is 28, plus 40 is 68. So 2 times 68, which makes 136. So that would be the area. But what about the volume? Well, here's what happens with volume. The volume, I just multiply all three of them, right? So I would say, since h is 2, and the width is 10, and the length is 4, it would be 2 times 10 times 4. 2 times 10 is 20, times 4 is 80. So the volume is 80. Now, you might be wondering, okay, why though? Like, we explained why the area is the way it is. What about the volume? Well, in the case of the cube, I want you to imagine something, right? I want you to imagine that we take this front face, right? And we multiply it. Now, what we need to figure out, the volume is basically saying, how many of these would we need to make up the entire cube? So you can see that you can see how we're filling up the cube, right? And the volume is basically saying how many of these would I need to fill in the entire cube? Well, that is something that depends on the length of this side. Because if this side is longer, well, this is a cube, so that wouldn't change. But here you can see if this side is longer, then I'm going to need more. So basically, the volume is if I take, no, not this. If I take this, the front face, right? How many would I need to make up the entire shape? So you can see now, it's like I'm sweeping through the shape, right? Well, this is basically asking how much the volume is basically like asking how many of these shapes would I need to stack together to make up this entire shape? Well, that depends on what the length is, because here where it's 10, I need to sweep quite a bit. But what if it was only like 3? I'd only need to go about this far. So I need much fewer. And that's why to find the volume, what I say is that I basically find the area of this front shape, right? So that would be the height times the length, so 2 times 4, for example. And then I multiply it by the width, because the width shows us how wide it is. So 2 times 4 times 10, right? Or 2 times 10 times 4, it really doesn't matter. We just multiply all three lengths with one another, and that's how we find the volume of the shape. Next up and last, we have the cylinder. Okay, so let's close the other two. So, the cylinder. The cylinder has two lengths that we care about. Its height, basically how tall it is, and the radius of the circles that it's made up of, the radius of the bases. To find the area, you have to consider that the area is made up of the tops of the bases. So here and here, the bases. And then what area does the body have, the connecting part, basically. So the area of the bases is, if we remember from our geometry when we were studying circles, that would be pi times r squared. So one circle, one base would have an area of pi times r squared. Two of them would be this plus itself. So if you remember what we said from before, we could write this as 2 times the area of one base. So 2 times pi times r squared. So that's this part. This part is the area of the bases. And then this, h times 2 times pi times r, that's the area of the connecting part, the part of the shape that connects the two bases. And so to find the area, we just add these two. So basically, if you are told that, let's say the height is 4 and the radius is, let's say 5, you just plug those numbers in. So radius is 5 and the height is 4. And you should also remember that pi is 3.14. And then you would do these calculations. Also keep in mind that exponents go first. So 5 squared should go first. Okay, to find the volume, we would just, I would say, the height, so 4 times pi times r squared. The reason for that, if you're looking to better understand it, is we have here one of the bases, right? Just like before, we need to consider how many bases, how many of these would we need in order to sweep through the entire shape. So that depends on how tall the shape is. If it's taller, we're going to need more, right? Whereas if it's shorter, we're going to need less. So that's why we multiply by the height to show basically that the entire volume of the shape is what I get if I find the area of one base and then just multiply it by the height of the shape. All right, now that we're done with that, I would like to take a quick moment to talk about the units of measurement of volume. All right, so I'm first going, oh, sorry. I'm first going to remind you about the units of measurement that we use in measuring surface. So when we have, let's say, a square that has sides of 6, we say that its area is equal to 6 times 6, so 36. But what if instead of just a number, I give you a unit of measurement? Like I tell you, okay, it's a meter, right? It's 6 meters. Then you'd have to do, okay, 6 meters times 6 meters, which makes 36 square meters, right? And what if I give you centimeters? What if I tell you that it's in centimeters? Well, then you'd have to do, again, 6 times, no. You'd have to do 6 times 6, which would again give you 36. This time, because the side was given to you in centimeters, would be 36 square centimeters. And if you wanted to correlate the two, you would have to remember that we have the ladder. So meters to decimeters to centimeters to millimeters. But when all of these become squared, then each step up or down needs multiplication or division, depending on if we're going up or down, by 100 instead of 10. So if this was square meters, square decimeters, and square centimeters, and square millimeters, and I wanted to go from one to the other, if I'm going up, that means I need to divide. And for each step up that I take, I need to divide the number by 100, sorry. So let's say 4,000 square millimeters would be how many square centimeters? 4,000 divided by 100, so 40. And then how many square decimeters? 40 divided by 100 again, so 0.4. And then how many square meters? 4.4 divided by 100 again, so 0.004. And I could make the opposite as well. I could make it go the other way. If I wanted to go down the ladder, we multiply, and for each step, we multiply by 100, right? So for example, 3 square meters would be 300 square decimeters, which would be 30,000 square centimeters, which would be, let's actually write that down. 3 meters would be 300 square decimeters, which would be 30,000 square centimeters, which would be 300,000 square millimeters. And now you might ask, okay, but why is that? And the explanation for that is that if this is 1 centimeter, right? Actually, no, let's make it a decimeter. If this is 1 decimeter, and I ask you to find the area, you'd do 1 times 1, you'd find 1 square decimeter, right? Well, what if I asked for the same area in centimeters? Well, you'd have to think that, okay, if this is a decimeter, then this is also a decimeter. But if we want centimeters, then we need to multiply this by 10, so it becomes 10 centimeters. 1 decimeter becomes 10 centimeters. And then I multiply this 10 times 10, and I get 100 square centimeters. So you see that although I only went from decimeters to centimeters, the number was multiplied by 100. And if I asked you to turn this into square millimeters, this would become 100 millimeters. And this would also become 100 millimeters. 100 times 100 makes 10,000 square millimeters. So you can see again, this number was multiplied by 100 to go from square centimeters to square millimeters. Although it's one step down, we multiplied by 100. And the reverse is true as well when we're talking about division. So all that's great, but what does that have to do with volume? Well, when it comes to volume, what we said is we need to multiply the height with the length with the width. Well, what if I give you a cube that has, for example, a side of 1 meter, a height of 1 meter, but it also has a length of a meter and a width of a meter. Well, you'd say 1 times 1 times 1, and which makes 1. And we'd call that 1 cubed, 1 meter cubed. 1 cubic meter, I'm so sorry. 1 cubic meter. So this is 1 cubic meter, right? But what if I asked you to give me that same area, but this time in decimeters, right? Well, 1 meter is 10 decimeters. But all of these need to change, not just this one side. They all become 10 decimeters. And now the area becomes 10 times 10 times 10, which makes 100. Sorry, 1,000. So 1 cubic meter is 1,000 cubic decimeters. And then what if I asked you to give that same volume, but this time in centimeters? Well then, to become centimeters, this would become 100 centimeters. 10 decimeters is 100 centimeters. So by multiplying all of them, we get 1 million cubic centimeters. As you can see now, when we're dealing with volume, when I'm moving from one unit of measurement down to the next, I'm not multiplying by 10 like we do with normal units of measurement. I'm not multiplying with 100 like we do with area. I'm multiplying by 1,000. So I want you to keep that in mind for your exercises this week, that when we are talking about cubic meters, cubic decimeters, cubic centimeters, and cubic millimeters, if this is the ladder, then when going up the ladder, just like before, we are going to divide, but for each step up, we divide by 1,000. And when we head down, we multiply, but for each step down, we multiply by 1,000. So for example, 3 cubic meters, 3 cubic meters is 3,000 cubic decimeters, because 3 times 1,000 makes 3,000. And 3 million cubic centimeters, and 3 billion cubic millimeters. Also, something else that I want you to keep in mind for your exercise this week, and this bit of information has more to do with something very specific, something that you've probably seen in physics, but I wanted to remind you. So your exercises talk about liters. And if you don't remember, liters are a unit of measurement of, they're also a unit of measurement of volume, just like cubic meters and cubic centimeters and all that. They're usually used to measure liquids. Specifically when measuring water, specifically for water, for every 1 liter, we have 1 kilogram of water. And this, again, is only for water. Well, only. This is for water, okay? Not most other things. Again, for every 1 liter, we have 1 kilogram. This, you'll need this information in your worksheets this week. So, and if you don't understand where you're supposed to use this, and you get confused, or you didn't understand maybe exactly what we did here with the conversions or anything like that, please make sure to come back to Friday's video so you can see how the exercises are solved. Okay, so that'll be all for today. I'll see you guys again on Friday.